This PowerPoint presentation is going to be on Sludge Age using the Gould Equation. As always, I claim no ownership to any of the questions or material presented in this video, as everything is sourced off the open internet. In the following slides, I have, to the best of my knowledge, presented the proper formulas and the correct answers to the questions. This is a study guide for wastewater treatment math. Doing this to help myself study. If it can help you study too, that's great. So the Sludge Age days formula off the state of Florida formula sheet that they give you when you take your test. Sludge Age days is equal to the solids inventory in pounds divided by the influent solids added pounds per day. As always, I recommend that if your state gives you a formula sheet, you get familiar with it, so when you're taking your test, you're not struggling. And one thing I'm going to do is I'm going to rewrite this formula, because this is how it's presented on the state of Florida sheet. The solids inventory pounds and influent solid added pounds per day. Well, what math is that? So we're going to pull those out. Solids inventory pounds. Solid inventory in pounds is the aeration tank capacity, million gallons, times the MLSS, milligrams per liter, times 8.34 pounds per gallon. It's just a pounds formula. Same thing with the influent solids added pounds per day. Influent solids added pounds per day is the flow, million gallons, the influent SS in milligrams per liter, times 8.34 pounds per gallon. So these are just pounds formulas. So sludge age days is equal to the aeration tank capacity, million gallons, times MLSS, milligrams per liter, times 8.34 pounds per gallon, divided by the flow in million gallons, times the influent SS, milligrams per liter, times 8.34 pounds per gallon. So that's just the sludge age days formula written out completely. A wastewater treatment plant adds 408 pounds per day of solids to its oxidation ditch, aeration lagoon. If the solids under aeration are 6,750 pounds, what is the sludge age in days? So I always like to pull out the known and the unknowns for my questions. So what we know is the solids inventory of 6,750 pounds in that aeration lagoon. We're going to be adding 408 pounds per day, and we're looking for the sludge age in days. We have our sludge age days formula, which is the solid inventory in pounds divided by the influent solid added pounds per day. There's no extra math in this one because they've already given us our solids inventory in pounds and our solids added in pounds per day. So you're going to go ahead and plug those numbers in. 6,750 pounds divided by 408 pounds added per day. And that's going to give you a sludge age of 16.5 days. Given in the following data, determine the sludge age in days for an oxidation ditch wastewater treatment plant. Mixed liquor suspended solids, MLSS, of 2,800 milligrams per liter, a ditch volume of 0.54 million gallons, and solids added of 575 pounds per day. So our formula for sludge age days is solids inventory in pounds divided by the solids added pounds per day. Well, if you notice, they did not give us the solid inventory in pounds, but they did give us the solids added pounds per day. So we're going to have to do an additional math step. The solid inventory in pounds is the aeration tank capacity, which is the same thing as your oxidation ditch, the times MLSS times 8.34 pounds per gallon. Now remember, solids inventory and solids added are essentially just the pounds formula, or the Davison pie chart. So you're just building blocks on top of math that hopefully you've already learned. So to get the solids inventory, we're going to do our 0.54 million gallons a day times the 2,800 milligrams per liter times 8.34 pounds per gallon. Solids inventory in pounds is 12,610. So we're going to plug our stuff into our formula. 12,610 pounds divided by 575 pounds a day gives you a sludge age of 21.9. You probably round that to 22 days. Next question. Calculate the days of sludge age using the following information. You have an aeration tank of 5,500,000 gallons. You have 2 tanks in service. The MLSS is 3,000 milligrams per liter. The average daily flow is 15.25 million gallons, and the influent TSS is 287 milligrams per liter. So this one's going to take a little bit more math. So we have our sludge age days formula. It's equal to the aeration tank capacity in million gallons times your MLSS milligrams per liter times 8.34 pounds per gallon divided by the flow million gallons times the influent SS milligrams per liter times 8.34 pounds per gallon. If you notice, our aeration tank is in gallons and not million gallons, so we're going to have to convert that. Also, there are 2 tanks in service. To convert your aeration tank 5,500,000 gallons to a million gallons, we're going to divide that by 1 million gallons. There are 2 tanks, so we're going to multiply it by 2. It gives us 11 million gallons. So we're going to go ahead and plug all our numbers in. We have 11 million gallons times 3,000 milligrams per liter times 8.34 pounds per gallon divided by 15.25 million gallons times 287 milligrams per liter times 8.34 pounds per gallon. If you did the math, the top number is 275,220 divided by 36,502.1. Do your division. And your sludge age days is equal to 7.54. Determine the age of the sludge in an aeration tank given the following data. Primary effluent flow of 2.13 million gallons a day. The volume of the aeration tank is 495,000 gallons. Mixed liquor suspended solids is 1,930 milligrams per liter, and the suspended solids is 68 milligrams per liter. We have our sludge age days formula. Aeration tank capacity, million gallons, times the MLSS, milligrams per liter, times 8.34 pounds per gallon, divided by the flow, million gallons, times the influent SS, milligrams per liter, times 8.34 pounds per gallon. Again, you notice our volume of our aeration tank is in gallons. We need to convert that to million gallons. 495,000 gallons divided by 1 million is going to give you 0.495 million gallons. So we can go ahead and plug everything into our formula. So our aeration tank capacity of 0.495 million gallons, your MLSS of 1,930 milligrams per liter times 8.34 pounds per gallon. You're going to divide that by the flow in of 2.13 million gallons, or effluent flow. So it's going in and coming out, same thing. Your influent suspended solids of 68 milligrams per liter times 8.34 pounds per gallon. And the answer is 6.6 days. How much solids must be added per day to a wastewater plant's oxidation ditch if the sludge age is 20.4 days and the solids under aeration are 2,460 pounds? So as always, I like to pull out my known and my unknowns from a question. So what we know is the sludge age is 20.4 days. The solids under aeration are 2,460 pounds, and we don't know what solids must be added. So sludge age in days is equal to the solids inventory in pounds divided by the influent solids added pounds per day. Well, what we don't know is the solids added, so we're going to have to rearrange our formula. So rearrange solids added pounds per day is equal to the solids inventory in pounds divided by the sludge age in days. So you can plug your numbers in. 2,460 pounds divided by 20.4 days. And the answer is 120.59 pounds per day. All right, so that was just a quick presentation, a couple questions on sludge age using the Gould formula. Hopefully this is helping you out, helping you practice and learn. Thanks.